Hi, I am Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this session, we are going to discuss about the Introduction to Digital System Design and Number Systems, representation of number systems. So the content today we are going to discuss what is signal, what is analog signal, what is digital signal, what is digital system design and what is the importance of digital system design and number system representation. So before going to the introduction, first we have to know what is signal. The signal is a function of one or more independent variables which contain some information. So for example, voice signal, video signal, speech signal, image signal or any telephone signal are comes under the signal. So here for example, I am taking here the signal is any physical quantity which varies with respect to time. So for example, I am taking voltage, either voltage or current. How this voltage or current are varying with respect to time. So that is also known as signal. So every natural signal, whatever we are talking, speech signal, audio signals, all comes under the signals only. So here are signals are two types, broadly categorized into two types: analog signals and digital signals. In the subject digital system design, it mainly deals with the digital signals only. Okay, so before we are going to know about the digital system design, first we have to know what is analog signal and what is digital signal, what is the importance of digital signal in the design of digital system. So here, what is analog signal? An analog signal is a continuous signal in which one time varying quantity represents another time based variable. In other words, one variable is an analog of the other variable. So here, both time and amplitude, both are in continuous nature in the analog signal. So we can get at any instant of time, we can get the amplitude. So both analog amplitude and time, both are in the continuous in the nature. So that is known as analog signal. Suppose I want to get the amplitude at the 1.1 seconds, I can get we can find the amplitude. If we want to find the amplitude at the 3.1, we can get find the amplitude value. So here both time and amplitude are both are in the continuous in the nature for the analog signal. So after sampling the analog signal, before going to know about the digital signal, we have to know what is discrete signal. So what is the difference between the discrete and digital signal? After sampling the analog signal, we will get the discrete signal. So here n represent the sample number and it is the amplitude. Okay. So here the time, here it is in the discrete nature, whereas amplitude in the continuous nature. In discrete signal, after sampling the analog signal, we are going to get the discrete signal. Here, the time is in the discrete in nature and the amplitude is in the continuous. Okay. After quantizing the discrete signal, after quantization, we are going to get the digital signal where the signal will be represented by either 1 or 0 only. 1, 0, 1, 1, 0. So that final output will be represented in the digital signal will be either in the zeros or ones. So first the continuous signal or analog signal will be sampled, we will get the discrete signal. After quantization this discrete signal, we will get the digital signal. The data represented in the digital signal in the form of either 0 or 1. So, what is the definition of digital signal here? A digital signal is a signal that represents the data as a sequence of discrete values. So, a digital signal can only take on one value from a finite set of possible values of a given time. So, with digital signal, the physical quantity representing the information can be many things, variable electrical current or voltage. So, either it will be 1100, 110, like that we will represent the digital signal. It will be in the form of either 0 or 1. So, what is digital circuit? A digital circuit is a circuit where the signal must be one of two discrete levels. So, total here in digital circuits, it deals with two levels, either 0 or 1. So, we can represent 0 as a true state, 1 as false state, or 0 as a low voltage level, 1 is a high voltage level, or 0 is on, 1 is off. Okay, so here each level is represented as one of two different states, either on or off, or low or high, true or false, or 0 or 1. So, 0 can be represented as true or low voltage value or in on state. 1 can be represented as a false state or high voltage value or off state. Okay. So, the digital circuits use transistors to create logic gates in order to perform Boolean logic. So, here the main applications of digital system design, whatever we are studying, we will use that application in the design of integrated circuits. So, where the integrated circuits are developed by the transistors. So, the transistor, the logics in the applied for the digital circuits are either 0 or 1. So, what is digital system design? We know what is digital signal and what is we have to know what is system. Then what is digital system design? So, here what is system? A system may be processed for signals may be processed for by the systems which may modify or extract additional information from them. So, here the signal is contains any information. So, those signals will be further be processed by the system to get the useful information from the signals. According to the application, we will extract the information from the signals by using the system. So, here if it is a system, for analog system, the inputs are in the analog, outputs are also in the analog nature. For digital system, the inputs what are we are applying to the system are digital inputs. We are going to get the outputs are in the form of digital only. So, a system is an entity that processes a set of input signals to yield another set of output signals. Okay. So, here the digital system design. So, digital system design is a process of designing or developing systems which represents the information using binary system, either 0 or 1. For examples, computers. Computers, if we type word or any letter or if we give any graphic, audio, any signal, it won't understand. It will convert those signals into binary form and it will you give the modifier, extract the information and it will give the output. Okay, so computers will not take the analog signal. It will convert the any inputs like graphics, audio signal or word, text. It will convert that into binary form, either in terms of zeros and ones, and it will process the inputs and it will give the output. So, for example, microcontrollers, microprocessors, memory elements, whatever we are using in the present applications, those all are in the digital nature only. So, here So it is the these microcontroller, microprocess, memory elements. What are the systems we are designing? So these will be used for the computer or any application, telecommunication application, control system applications, in present electronic applications. We will use these digital systems. So it is the implementation of IC chips over several transistors used in a wide range of applications, including information that is nothing but computers, telecommunications, and control systems. Advantages of digital system design. Here, it is easier and cheaper to design compared with analog systems, and reproducibility of results. So if we design analog system, this will be either active or passive elements, op amps, resistors, or inductors or capacitor, op amps, or any active or passive elements. If we want to change the functionality of the output, so we have to change the components of the analog systems. We have to redesign the analog system. But whereas in the digital system, we can reproduce the result by changing the algorithm. So here the reproducibility of the digital system is easy compared with the analog signals. And flexibility and functionality is better than analog signal. The speed, according to the speed, also it has the advantage, and programmability. We can reprogrammable the ICs. Now we are getting programmable devices where we can reprogrammable the design, and we can use that digital design for another application. So here we are going to discuss about the basic topic of digital system design is number system. So what is number system? The number system is simply a system to represent the information or express numbers. We use the number system in the digital system. So here, to represent the information or to express the numbers, we use the number system in the digital system. For example, if we want to store the any data in the memory, in terms of in the memory, suppose if you have a computer, you have the RAM or ROM memory. So if you want to store the memory, that will be stored in terms of either binary. If for large memory system, it will be either be hexadecimal or octal number system. So according to the application, we will use this number system. So the number systems are divided into here mainly decimal number system, binary number system, octal number system, and hexadecimal number system. So here now we are going to discuss the basic representation of these number systems. So decimal number system. So in our daily lives, we are going to use the number system is called number system. Suppose 10 rupees, 100 rupees. Suppose any number we are telling, that is in terms of decimal number system. So the base for decimal number system is 10. I will tell what is base. Okay. And for binary number system, the base is 2. And for octal number system, the base represented is 8. And hexa number system, the base is represented by 60. Okay. Suppose I want to represent a number 101011 base 2. Means the number is in the binary form. Binary number system. Okay. Suppose I am representing. So the base, by seeing the base, we can see which number system that the number belongs to. So here base is 8, means that number is the octal number. If it is the base is 16, means it is the hexadecimal number. Okay. Suppose 1, 3, base 10 means the number is in the decimal number. By seeing the base number, we can tell that number is either decimal number or binary number or octal number or hexadecimal number. So what is how we can represent a number? So here the value of any digital number can be determined by the digit, its position in the number, and base of the number system. Okay. So here 1, 2, 3. For example, I am taking the 1, 3, 2 base 10. Okay, the digit represents 132. Okay, and base represents 10, and the position in the number. So we will write from right to left 0, 1, 2. So the 0th position, the digit number is 2. So these are the position of the number 0, 1, 2, and 10 is the base, and digit is 132. Okay. So by seeing these numbers, we can represent which number system that number belongs to. So for example, so here first we have to know what is radix or base. The value representing particular number system is known as radix, either 8, 16, 10 or 2. 10 represents decimal number, 2 represents binary number, 8 represents octal number, 16 represent hexadecimal number. These are the radix numbers. By seeing those radix numbers, we can tell which number that belongs to. So if the base or radix of a number system is represented by R, so this R represents the radix or base. So which number system that number belongs to, by seeing this radix number we can tell that. So here if it is radix is R, means that number, suppose base 2, binary number represent 2. So here radix is called 2. So the binary numbers we will get in the binary numbers R minus 1 numbers only. So in binary the numbers will be represented by either 0 or 1 only. Okay, I will explain this one. The total number present in the number system is R. So for example, so number is A4, A3, A2, A1, A0 dot A minus 1, A minus 2, A minus. Suppose this is the number. Okay, this is the digit, the number. The base radix is 8. By seeing this radix, we can represent that belongs to octal number system. Okay, this is the octal number. Okay, so here the numbers here A4, A3, A2, A1 dot. So here the it has 2 points, integer part and floating point. Okay, so here in the integer part, the left side before that decimal point we will that is the integer, and right side it is the floating point. So here this is A minus 1, the position represent A minus 2 and A minus 3. Okay, the radix will be here R power 0, R power 1, R power 2, R power, that is nothing but 8 power 0, 8 power 1, 8 power 2, 8 power 3. This is 8 power minus 1, 8 power minus 2 and 8 power minus 3. Okay, here already the base of the number system, its position in the number. Okay, so here it is 0th position, first position, second position, third position. So this is the number, basic number system representation. So first we will see the what are the numbers we are going to use in the decimal, binary, octal and hexadecimal number. So we know already what is decimal number. The base, if the base is 10, then the number is called decimal number. So in that decimal numbers, we will use the symbols from 0 to 9. Here the radix we are using R is equal 10. The base is 10. The numbers we are going to use is 0 to R minus 1. So 0 to 9 numbers we will use in the decimal number system. Okay. For example, if it is binary system, the base is here R is equal to. So here we are going to use 0 to r minus 1. That is 0 to 1. Only two numbers we are going to use here, 0 and 1. Okay. In octal number system, the base is 8. So r is equal to 8. So here we are going to use 0 to r minus 1, that is 0 to 7 numbers we are going to use here. So that is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Total we will use the r numbers. We will get the r symbols. Okay. So 0 to 7 we have 8 numbers. But we will use only 0 to r minus 1. Okay. Hexadecimal, the base is 16. Okay, so here we are going to use 50 numbers. R is equal 60. So it is 0 to r minus 1. That is 0 to 15. So 0 to 15. But here the representation is after 0 to 9. The 10 will be represented by A. 11 will be represented by B. And 12 will be represented by C, 13 D, 14 E, 15 F. Okay. So 0 to F, total 16 numbers we are going to use in the base 16, that is hexadecimal number. So we have to remember this base of the number system. What are the numbers we are going to use in that number system? So here in the decimal, the base is 10. Here we are going to use the numbers 0 to 9. In the binary system, by that is nothing but two numbers, only 0 and 1. Octal, 8. The base is 8. We are going to use the numbers 0 to 7. In hexadecimal number, the base is 60. Here we are going to use the numbers from 0 to F. Total 60, 0 to F. Okay. Here in the hexadecimal number, A is represented by 10, B, 11 is represented by B, 12 is represented by C, 13 is D, 14 is E, 15 is F. So first we will discuss the decimal number system. Okay. So the base or radix of decimal number system is in the base is 10. Okay. So if it is the number 8672.34, if the base represented by 10, then it belongs to decimal number system. So that is the decimal number. So the numbers ranging from 0 to 9 are used in this number system. So here whatever the numbers we are using, we have, those will be from 0 to 9 only. So here 0 to 9 are used in this number system. In our daily lives, we are using this decimal number system. We are representing this decimal number system as examples. The part of the number that lies to the left. So here I have 8672.34. Okay. 8672.34. Okay. This dot represents decimal point. So the part lies left of the decimal point is known as the integer part, and the point to the right side, the values whatever we have, that is the fractional part. Fractional part. Okay. So how we should represent? So here this is the base 10. The position of the numbers, by seeing this decimal point, the left side we will increase 0, 1, 2, 3, and right side -1, -2. The weight of that number will be 10 to the power of -2, 10 to the power of -1, 10 to the power of -2, 10 to the power of 0, 10 to the power of 1, 10 to the power of 6, 2, and 10 to the power of 3. Okay. Here, if we find the weighted values of this decimal number, for example, so here the weight of this one is I can write 8 into 10 to the power of 3 plus 6 into 10 to the power of 2 plus 7 into 10 to the power of 1 plus 2 into 10 to the power of 0 plus 3 into 10 to the power of minus 1 plus 4 into 10 to the power of minus 2. So, this is 8000 plus 600 plus 70 plus 2 plus 0.3 plus 0.04. If we add this total value, we will get that as 8672.34. It is equal to the weighted sum of the individual position of the number. Okay. So, here 2 is the 10 to the power of 0, 7 into 10 to the power of 1, 6 into 10 to the power of 2, 8 into 10 to the power of 3. Here, right side of the decimal point, it will be 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3, that will be increased here. Okay. So, binary number system. So, in the binary number system, the number radix is 2. So, in binary number system, the radix is 2. By seeing the radix 2, we can say that is the binary number system. So, the digits whatever we are using in this binary system, that will be in terms of only either 0 or 1. 1 0 1 1 0 0 1. Okay, like that. Otherwise 1 1 1.01. Okay, here in the digits either represented by either 0 or 1. Only 2 digits we will use in the binary number system. Each position in a number represented a 0 power of the base 2. Okay, like 2 power 0, 2 power 1, or 2 power minus 1, 2 power minus 2. I will explain that one. Last position in a binary number represents an x power of the base 2. So, suppose this is the x number, the weight of that number is 2 power x. Okay. For example, 1101 base 2 is the binary number. So, here the radix is 2. For example, I want to find out the weighted sum of the individual digit here. So, this is position 0, 1, 2, 3. So, binary number system. So, r power 0 plus r power 1 plus r power 2 plus r power 3. Okay, we will use that weight of that system. So, here 2 power 0, the weight of this position 1 is 2 power 1, the weight of the position 2 is 2 power 2, the weight of the position is 2 power 3. So, if we add the total weight of the digits, we will get the same numbers. See here. So, it is the 1011. So, that will be represented as 1 into 2 power 3, 1 into 2 power 2, 0 into 2 power 1 or 1 into 2 power 0. So, here first we will have to know what is the radix number, what is the digit weight of that number and position of the number. Okay. So, here octal number system. Octal number system, the base is 8. Here we will use the 0 to 7 numbers, total 8 numbers that starts from 0 and end with 7. So, here it uses the digits. Whatever digit we are using, the digit will be range from, here we are using digits. Suppose it is 6, 5, 4, 2. Okay. Each digit, the range is from 0 to 7 only. Okay. Uses 8 digits 0, 1, 2, 3, 4, 5, 6, 7. Also called base 8 number system. We can call this as a base 8 number system. Each position in an octal number represents a 0 power of the base 8. So, the first position, for example, this is the first position 0, 1, 2, 3. So, the weight of this number will be represented by 8 power 0, 8 power 1, 8 power 2, 8 power 3. The last position in an octal number represents x power of the base 8. So, that is 8 power x. For example, this is the x position. The weight of the digit is 8 power x. So for example, 3, 4, 5, 2.12 octal number base 8. By seeing this radix, we can say this number is a octal number, and the octal point, we are whatever the point, the left side 8, the first write down position 0, 1, 2, 3. Right side for the octal point is -1, -2. Okay. The weight of the particular digit is 8 power 0, 8 power 1, 8 power 2 and 8 power 3. 8 power -1, 8 power -2. Okay, so here 3 into 8 power 3 plus 4 into 8 square plus 5 into 8 power 8 plus 2 into 8, 1 into 8 power -1, 2 into 8 power -2, we will get the same weighted sum of the individual digits. So hexadecimal number. So in the hexadecimal number, the base is represented by 60. So here the base is 60. Okay, each digit, whatever digits we are using, okay, each digits, the range is from the 0 to f, either from 0 to f. So here the total we are going to use 10 digits, 0 to 7, 10 digits and 6 letters. Okay, so here the 10, after 9 we are going to get the 10. The 10 in the hexadecimal number system, it is represented by the A, 11 is by B and 12 is by C and 13 by D, 14F and 15F. 14E and 15F. Okay. So the letter represent the number starting from A, B, C, D, E, F. 10 is A, 11 is B and 12 is C and D is 13, E is 14, F is 15. We can't write directly 10 in the hexadecimal number. Okay, and it is also called as a 60 number system. Octal is 8 number system and hexa is a base 60 number system. So each position in the hexadecimal number is represented by the starting point will be represented by the weight of the digit will be 16 power 0, 16 power 0, 16 power 1. Position is 0, 1, 2, 3, 4. So 16 power 1, 16 power 2, 16 power 3 and 16 power 4. Okay. If it is a fractional point, 16 power -1, 16 power -2, 16 power -3. Okay, we can represent that weight of the individual digit. Okay. So here for example I am taking 1A05 point something, 1A05 E2. So if the base is 16 means it belongs to hexadecimal number system. So how to find out the weight of the individual digit in the hexadecimal number? So first write down the position. So here the hexadecimal point, the left side it 0, 1, 2, 3. The position of the digit, it is -1, -2. The weight of the individual digit will be represented here is 16 power 0, 16 power 1, 16 power 2, 16 power 3 into 16 power -1 and 16 power -2. That is nothing, we can write that as 1 into 16 power 3 plus A into 16 power 2 plus 0 into 16 plus 5 into 16 power 0 plus E into 16 power -1, because this is the right side of the decimal point. So 16 E into 16 power -1 plus 2 into 16 power -2. Okay. So there we can have the total weight of the individual digits by using base 60. So these are the basic representation of number system. So for decimal number system, the base is 10. The base is 10. For binary number system, the base is 2. For octal number system, the base is 8. And hexadecimal number system, the base or radix is represented by 16. So, how to represent basic numbers in the decimal, binary, octal and hexadecimal numbers. So, here in decimal number system, the basic numbers is from 0 to 9. Okay. Next, it will be 10, 11, 12, 13 up to 50. So, in binary number system, the digits will be, numbers will be represented by either 0 or 1 only. Okay. So, first 0 will be represented by 0, the 1 will be represented by 1 and 2 will be represented by 1, 0 and 3 will be represented by 1, 1, 4 will be represented by 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, 7, 1, 1, 1. Okay. Octal number system. See, if we find out the weight, for example, I am taking 4. So, 1, 0, 0. Okay. So, it is in the base 2. So, 2 power 0, 2 power 1, 2 power 2. Okay. 2 power 3, 2 power 4 like that. The weight will be increased in terms of 2 powers. Okay. So, for 1, 0, 0, it is 2 power 0, 2 power 1, 2 power 2. That is 1 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. That is 4 plus 0 into 2, 0 plus 0. That is 4. So, the 4 is represented by 1, 0, 0. We can, if we want to convert that 4 into decimal into binary number, 2 2 ja 4. The remainder is 0. 2 1 ja 2. Remainder is 0. So, write this value 1, 0, 0. 1, 0, 0. From down to up. So, in next class, I will explain the conversion of the numbers. How to convert the decimal to binary, octal and hexadecimal, binary to other number system, octal to other number system, hexadecimal to other numbers. So, just I am explaining how we are going to represent numbers. Okay. So, in octal number, we will write 0 to 7. Only up to 0 to 7 digits we will use. The 8 will be represented by again 1, 0. 8 will be represented by 1, 0. 9 will be represented by 1, 1. Because we will use from digits from 0 to 7 only. So, after 7, the 8 will be represented by 1, 0. 9 is represented by 1, 1. 10 is represented by 1, 2. 11 is represented by 13. 12 is represented by 14. Okay. How we can represent means 8 means 7. We have to find out this LCM from 7. 7. 1 ja 7. The remainder is, so, octal number. So, the base is 8. So, 8 1 ja 8. The remainder is 0. So, 1 0. So, 8 is represented by 1 0. Suppose for example 13. How to represent the 13 in the hexadecimal number? So, 8 1 ja 8. The remainder is 5. So, 13 is represented by 15 in the hexadecimal number, octal number. Okay. So, here after 7, from 0 to 7, we will use the numbers in the octal number. After 7, the 8 will be represented by 1, 0, 9 will be 11, 10, 12, 11, 13, 12, 14, 13, 15, 14, 16, 15, 17. Okay. In hexadecimal number, we will use the total 16 numbers. In that, 10 are digits from 0 to 9. After that, we will use the 6 letters A to F. So, here after till 9, we will use the 9. The 10 is represented by A, 11 is represented by B, 12 is by C and 13 is by D, 14 is by E and 15 is by F. Okay. For suppose 16, we have to represent in the hexadecimal number, then that will be represented by 1, 0. Because 16, so The base is 16. 16 1 is 16. The remainder is 0. So 1. The 16 is represented by 1. Next 1, 1, 1, 2. Like that 1A, 1E, 1F up to 1F. Okay. Like that these are the basic number systems. Decimal, binary and octal hexadecimal number systems. So here we are going to use the reference books for this subject is Modern Digital Electronics by R.P. Jain or John F. Curley, Digital Design Principles and Practices. We can use these books for the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.